resume.
Thank you. The last part of your addendum I want to go to is the table 3, which is just following this table that's on the screen. All right, and this table, I just want to identify that it replaces table 4.7-1 that's in the main report.
That's correct.
Okay, and it is a summary of all of the analyses that you've done for each life stage, basically taking the likelihood column and importing it for each life stage, is that right?
That's correct.
Okay, and we would like to use the addendum one because it includes the fish farm issues,
Yes.
and that's on the following page, if you could just keep scrolling up. That's the full table. Okay, thank you. Now moving back to the main report, table 4.7-2. This is the very last section of your report, and I'd like you just to explain what, well, first of all, there's an errata. We might as well clear that up right away. That's on the following table. You've got two tables here, 4.7-2 and then 4.7-3. There we go. So there's an errata correction that you wanted to make on the first column there, the header.
Yes, so the first two columns state life stage, and the first column should be stressor category, i.e. Cohen Commission technical report.
Okay, thank you. Now, with these two tables that we've just thrown up on the screen with no explanation yet, what are you actually showing us here? What was the analysis that was done?
So we are looking at the relative ability of different combinations of variables to explain the observed changes in sockeye life cycle productivity, somewhat similar to the Queen Charlotte Sound Strait of Georgia analysis we talked about previously. So what we did for that is we carefully lined up all the explanatory factors to match the life history stages and age structure of each of the stocks. So for example, April to August sea surface temperatures in the Strait of Georgia. And for the first table, we grouped those explanatory factors by life history stage. If you could please go back to table 4.7-2, that's great, just at the top. Yeah, so as you can see the column headings there. So we have incubation to lake rearing, outmigration, coastal migration, and so on. And the X's in shaded gray cells here represent the variables that were included in that model. So M4, for example, coastal migration, includes Strait of Georgia discharge and so on down there. And so we were basically curious about which of the life history stages had the explanatory factors that were most correlated with the overall life cycle productivity, given the data that we had. And then the following table, you don't have to go there, we just looked at it, is we grouped the explanatory factors according to the technical reports. So each of the technical reports that were received, so for example, we would use just the contaminant information, or we would use just the predator information. Rather than organizing it by life history stage, we just organized it by report.
Okay, and what conclusions did you draw?
So for the table we're looking at here, table 4.7-2, I wonder if there's a better table to see. I guess that's the best one. Leave it there. That's fine. So for that table, the three models with the highest relative level of support, again, these are relative levels of support, included, the first was the model which included factors for all of the marine life history stages. The second was a model with the factors for the coastal migration stage, and the third was factors was the life history stage for the return to the Fraser. So over this time period and given the data we had available from 1969 to 2001, the marine phase factors appear to have the best ability to explain the patterns in productivity. And then when we looked at the analysis by the Cohen Commission project, the model with the highest level of support included all 34 factors, so basically throwing everything into the soup. And the factors, when we looked separately at the separate reports, the ones which came next was a model with data for predators and alternative prey, and factors for the lower Fraser Strait of Georgia. And so it was a bit surprising that the best model would be the one with all the factors, because the criterion that we're using to assess the relative level of support, AIC criterion, penalizes models which have a lot of variables in it. So overall, the bottom line is that from the life cycle analysis, the marine phase factors appear to have the best ability, and we generally we conclude that it's best to look at this using a life cycle approach rather than a project approach.
Okay. And then page 95 of your report, which follows these tables relative, in the paragraph above, the relative importance of different stressor categories, you state at about lines 9, so about halfway through that paragraph, that the strength of any conclusion that freshwater life stages are not as important as marine life stages can only be as strong as our belief that the assemblage of variables described above is a reasonably accurate representation of the freshwater component of the life history of Fraser River sockeye salmon. What does that mean?
So all of these results are only as good as the data that you put into them, and for the freshwater life history stage, there really weren't many data sets available within the time we had, and may not be available, period. So, for example, we had to use air temperatures instead of lake or stream temperatures as a proxy variable for freshwater conditions. So ideally, you would have a lot more data on freshwater conditions.
So if we accept that the freshwater life history stages are not as important as marine life stages in describing their productivity decline, does that mean that freshwater stressors are having no impact on productivity?
No, it doesn't mean that. And first of all, you have to remember this is only one part of what we did. This quantitative analysis is supplemented by the main part of the report, where we're looking at all the results from Technical Report 3 by Nelitz et al. And Technical Report 12, and looking at all of that information. So all it means is that within this particular analysis, that the freshwater indicators we had in our database were not as strongly correlated as the marine indicators with changes in life cycle productivity. One other thing I should point out in passing is that all of these models included the spawners, allowing for density-dependent effects in a Ricker-style model from the parent generation subsequently to the overall life cycle productivity. So you can think of that as that if there were significant density dependence, and there is, because the coefficients for spawners are always negative in all of these models, so that's carried through in the analysis. That's you can think of it as a freshwater event, number of spawners, that has ramifications over the entire life cycle.
And looking at these models that this section is dealing with, there's a comment by one of the reviewers, Sean Cox, that there's no indication of variation in salmon productivity explained by the alternative models, and he comments that no R-squared values were provided. So I just wanted to talk to you a little bit about that. First of all, what is an R-squared value, and how does it help us understand how well a model explains the data being assessed?
So R-squared is also called the coefficient of determination. So it's the fraction of the total variability in a dependent variable, and in this case, we mean the total variation in sockeye productivity, log recruits per spawner over all 18 stocks. That's explained by the variables that you include in a given model. So a simpler example would be, you might say, well, 70% of the variation in somebody's income, or in people's income over a sample, is made up by their level of education and their level of work experience. And so in that case, R-squared would be 0.7.
Okay. Without those R-squared values, are you able to say that one model with a certain set of variables can explain the changes in productivity better than another model?
Yes, we can still say that one model has more support in the data than another model. The AIC criterion that we use tells you the relative level of support, which is what we were interested in because we were looking in a retrospective way. It doesn't tell you the total proportion of the variation in productivity that is explained. And if we'd had time, we would have included the R-squared in the program that we ran for this. We didn't output the R-squareds for all the all the analysis. We had about 3 weeks from the time we got all the data to finish the report. So it was quite a crunchy time. And so it's a good suggestion that Sean Cox made, and we could certainly go back later and do it.
Okay. Without those R-squared values being included, what we couldn't say, for example, is that, we could say, for example, that Model 10, as you've done, describes, which looks at marine variables, that it describes productivity better than variable models that look at variables in other life stages. But what we can't do is assess the percentage of the variation in the data that's actually explained by Model 10 or by any of the other models. That's what you're telling us.
Yes, that's correct. I'll just note in passing something that I looked at the Connors et al. Report, and although it was a very different kind of model, it didn't have as many covariates included in his long-term analysis. He had R-squareds around 0.7. He also included sea surface temperature, also included spawners. So although we haven't calculated, my suspicion is that we would have R-squared values in the same general ballpark.
And for the purposes of your analysis, which you, as you said, was a retrospective analysis, you didn't think that R-squared values were important to have?
It's not as critical if you're not if you're attempting to create a model which you hope to apply prospectively, that is to make predictions in the future. It's not as critical to have it. There's also some limitations in R-squared because the R-squared doesn't take into account the number of parameters used to fit a model. There is an adjusted R-squared measure that does take that into account. So the AIC measure was, I think, adequate for what the purposes that we wanted to use, looking retrospectively. I'll just point out that if you had a set of models and all of them had the same number of parameters and you used both R-squared and AIC, it's likely that the rank order of those models would be similar. Because AIC is considering to what degree the model variables explain the variation in the data.
Right, but you couldn't say that without the R-squared value, you couldn't say that the marine explains 70%.
Correct.
So it could be better than the other ones, but it could be that the other ones are 1s and marine is a 2.
No, that's right. You don't know the absolute proportions.
Okay. Then moving on, I'm running out of time, so I want to just go quickly through a couple of things. On page 100, table 4.8-1 sets out other factors which could potentially contribute, and you've set them out clearly, but I wonder if harmful algal blooms should be added to that list. Sorry, Mr. Lund, you can just keep moving it forward.
Yeah, I think I just hit the wrong page.
Okay, there we are.
Yes, it should be.
Okay, thanks. Then the last section I'd like to go to are the conclusions and some of the recommendations that are set out. So at page 104, at the top, right, talking about what happened at the PSC panel, it says there was a consensus among the group that a focused oceanographic and fisheries research program targeting the Georges Strait, Queen Charlotte Sound, and extending along the continental shelf of Alaska would be useful. Have you given any thinking to who should participate in such a thing and how it would be structured, or who would be responsible to organize or fund it?
So that question wasn't really part of our terms of reference, but I think the first thing would be to clearly set out the objectives for the research group. So what decisions are you hoping to inform? What level of accuracy and precision is required for those decisions? And what are the scientific questions that help to inform those decisions? So rather than just going out and doing a bunch of research. Logically, I think it would be led by the federal agencies responsible for Pacific salmon, so that would include DFO, NOAA Fisheries, Pacific Salmon Commission, I guess that's an international agency. And then they would get data and have participation from a whole bunch of others, so leading researchers, international organizations like Pisces, Alaska, Washington, Oregon, Idaho state fisheries agencies, First Nations, NGOs, provincial agencies, fish farmers. So, but it would be led, I think, by those federal agencies. That's just my, off-the-cuff thinking on this.
And then you also talk about database improvements being needed and being identified as a problem among the researchers. What's needed and how would it be accomplished?
So I think the first thing is to have excellent data on Fraser River sockeye and non-Fraser River sockeye productivity and stressors, and to know exactly where those data came from. And then to design a database that way so that it facilitates answering the specific questions and making the specific decisions that I described earlier.
And who would maintain such a database and fund the effort?
Logically, I think it would be the same agencies, the federal agencies that I described earlier. They're the ones who have the most data, and they would get other data sets from other people.
Right. And in preparing your report, Technical Report 6, you actually created a fairly extensive database, is that right?
Yes.
And is that database useful for future analysis?
Yes, I think so. It was done for internal use, so it doesn't have a user's guide and all the other things that one would want to have before it were made public, and it would also be good to add some of the stressor variables for the non-Fraser stocks. But I think it's a reasonable start.
Okay. And then you have a set of recommendations set out set out in a table, table 5.2-1. It's on page 108 is where it begins. And in each of these, in the column called comments and recommended research and monitoring activities, we see various recommendations being bolded. What is that? Why are you bolding things? What does that indicate?
So I think we had, I don't know, was it 24 or something recommendations, something like that, and we thought it was important to highlight those which were relatively more important, recognizing that the final prioritization is something that would have to go through a quite extensive process of thinking about the decisions that need to be made and inputs to those decisions, the required precision of information for those decisions. Notwithstanding that, we looked at this and you see there's two columns there, one on explanatory importance and one on relevance to management actions. So explanatory importance means what's the relative ability of information within each of those rows, each of those life history stages, to explain what's going on. And relevance to management actions is, well, how much would that information be used for actually making decisions on, say, harvest, habitat, hatcheries, hydro. And so we basically used those columns as a guideline for bolding certain portions. So if you go down a little further to the section on coastal migration, everything's bolded because we have, from our work and from the work done by the various technical reports, concluded that the coastal migration phase has a high level of explanatory importance. It's also highly relevant to management actions.
And do you have any suggestions to throw out there on how to prioritize all these different recommendations?
So if you could go, Mr. Nunn, to page 107. Down there, the questions there. So I think I've already described these, and so in the interest of time, maybe easier for folks to read this than for me to read it. I think the key things are, what are the decisions, what are the inputs to those decisions, and how much information do you need? So if you think about pre-season forecasts, how much precision do we want to have on that? Do we want to be able to say, well, things are likely to be relatively poor, average, or relatively good? Or do we want to be much more precise than that? That affects how much information you need. And then it's also sequencing the efforts. So having certain rules, the sort of contingent rules. If we learn something, then we might need to do something else. And also, what are the cost-effective trade-offs? So for example, you need to consider how much budget you have, and you might not want to sacrifice your in-season monitoring programs to get better pre-season estimates, for example. So there are trade-offs there that have to be carefully considered.
Thank you. Those are my questions, Mr. Commissioner. So Canada will be first, and they've got a 30-minute allocation.
Yes, Mr. Commissioner, it's Tim Bergen, Charles Fougere for participant Government of Canada. I'd like to start, Dr. Marmorek, with your role as a facilitator at the June 2010 Pacific Salmon Commission workshop. And if we could have Exhibit 73 brought up, thank you. If we just look at the title page there, I note your name's there under prepared by, it says Dr. Peterman and then yourself. Can you explain for us what your role was at the Pacific Salmon Commission workshop?
Sure. We were working with both the Pacific Salmon Commission, Department of Fisheries and Oceans, and NOAA Fisheries, a committee to design the workshop. And so that committee met and discussed which hypotheses should be included. We facilitated those discussions. Prior to the workshop, we developed some forms which are included in this report for participants to comment on evidence they felt was relevant. At the workshop itself, we served largely as timekeepers, and subsequent to the workshop, the panel met, led by Randall Peterman, and assembled the main portions of the report. And we worked with the panel and with Dr. Peterman to help pull all that together. There were various further conference calls with the panel on key points that we helped to facilitate.
Okay, thank you. And did you personally contribute any science research yourself to the workshop? Or were you just a facilitator?
Wouldn't say just a facilitator. Yes, we
Fair
We
enough.
did not present any independent research, and we worked to integrate the information that was presented. For example, the table that's in this report of evidence for and against, I prepared, which was based entirely on what the panel had written, but it was just a summary.
If we could then turn, to refresh our memories, we've got at page 4 of this document, we've got the 9 hypotheses. And the panel at the top of page 5, if we could look at that top paragraph there. So here, this is under the, I guess, the executive summary. It says the panel, I'm just reading from the document, the panel concluded that the available evidence for and against each of the 9 hypotheses does not point to a single cause of either the poor adult returns of Fraser River sockeye in 2009 or the long-term decrease in returns per spawner. Do you still agree with that statement?
Yes, I do.
And so we're not looking for one, there's not one hypothesis out there that explains what we've been seeing.
That is correct, though I think it's fair to say that some are more likely than others to be primary causes.
Right, thank you. And then continuing on with that executive summary, it says, instead, the evidence suggests that multiple causal mechanisms very likely operate simultaneously, and their effects may be additive, multiplicative, synergistic, or may tend to offset one another's effect. And do you still agree with that?
Yes, I do.
Thank you. And if we could then turn back to your, and then at page 9, just for to refresh our memories, is the table E.1, where the Pacific Salmon Commission set out their various hypotheses. If we could turn then to your report exhibit at page 36. So that's exhibit 1896. Oh, sorry, I'm at the wrong page. It's the second last page of the executive summary. The pages are not numbered, unfortunately, Mr. Lam. It's right at the very beginning. It's a section that's titled Recommendations for Research, Monitoring, and Synthesis. There we go. And here I'm just noting that under this section, you start off by saying researchers at the Cohen Commission workshop agree with the Pacific Salmon report. and it goes on, and that's really part of your conclusion with your report. Now they're consistent. I guess that's my main question, is would you agree that both the Pacific Salmon Commission report from June 2010 and your paper have very similar conclusions?
Yes, I would. I think the only distinction is that we had more information, particularly on non-Fraser stocks, and also had some more information on marine conditions, which slightly changed but didn't radically change the conclusions.
The membership at the Pacific Salmon Commission workshop and the scientists that worked on your ESSA report, you'll agree that those are different scientists. Despite the fact that you were at the Pacific Salmon Commission, the scientists at the Pacific Salmon Commission were different than the people who worked on the ESSA report.
Yes, they are different. However, I think it's important to note that our report is a synthesis of the technical reports done by all the Cohen Commission researchers. So I actually think of our team as including all the people who worked on those reports as well.
Right, and so you'll agree that despite the different scientists that were involved, they came to a very similar outcome.
Yes, I think there's, as you would expect among scientists, some interesting arguments between was Queen Charlotte Sound or Strait of Georgia more important in 2007, but in general, people agree.
Okay. I'd like to now just ask some questions about the stage 1 of your report. And I've got just a couple of questions. We'll just walk through the life cycles as you put them out. So here, with respect to stage 1, you state that you say that climate change is a possible factor with respect to the causes of decline for stage 1. And you talk about climate change throughout the report. So I'm just wondering, what's your definition of climate change? What do you mean when you say climate change is a possible factor?
Okay, so there's two questions there. So my definition of climate change would be the increase in greenhouse gases and associated changes in both temperatures and circulation in the ocean and other factors driven by that increased amount of heat in the atmosphere. And here we were following or synthesizing the work that Scott Hinch and Eduardo Martins had done in their climate change report, in which they noted that temperature changes could have both positive and negative effects on incubation, emergence, and freshwater rearing. And so we carried that through as a possible factor. It had exposure in the sense that temperatures have been shown to be increasing, certainly in the Fraser, and other data show temperature increases in many tributaries. So it remained a possible factor.
So when you say climate change, are you seeing that as increased variability, or are you seeing that as an increased general temperature rising?
Certainly both occur with climate change. In this context, for this specific section, we were relating it more to increases in temperature because that's what Scott Hinch and Eduardo Martins had referred to.
Will you agree that climate change manifests itself in a variety of factors then?
Absolutely.
Okay. And will you agree that climate change is not a mechanism per se?
A mechanism of causing mortality, is that what you mean? Or a mechanism for what?
Well, it's not a separate factor onto itself, that it's a combination of factors come together when we think about climate change.
I guess I'd describe climate change as a driving force which can ultimately affect sockeye through many different mechanisms in many different life history stages, if that's what you meant. That's certainly how I would describe it.
And how is climate change then different from changing marine conditions?
Well, first of all, climate change can also occur in the freshwater part of the life cycle, not only in the marine system. So the various mechanisms that are discussed in the climate change report include both changes in freshwater as well as changes in marine systems. So Hinch and Martins talk about, for example, in the marine side, climate changes in temperatures can affect food conditions, can affect prey, can affect predators, can affect competitors. Obviously, marine conditions are strictly in the marine. They're going to be influenced by climate change, but climate change is larger than that. So changes in hydrology, for example, over freshwater, as well as changes in temperature, incidents of extreme weather conditions, those are all climate change mechanisms which would not occur in the marine system.
So then, with respect to stage 1, you've going back to your executive report, you say that we feel, and I'm reading from your report, quote, that we feel confident in this conclusion because juvenile productivity has not declined over 8 of the 9 Fraser sockeye stocks where it has been measured. So, can you explain what you mean by that statement there?
In 9 of the stocks, we have some measure of juveniles per spawner. In 7 of those stocks, it's fry per spawner. In 2 of them, it's smolts per spawner. And in 8 out of the 9, and those data are listed at the back of the PSC report, there hasn't been any trend over time in juvenile productivity, either an increase or a decrease. And in the 9th, which I believe is the Gates sockeye stock, there has been an indication of some decline.
All right. And so based on that, then you conclude that you can eliminate a whole suite of stressors as being a likely cause of decline as a result of this conclusion, right? And then you list these factors that we see before us: forestry, mining, large hydro, small hydro, etc.
No, that's the way you stated it isn't the way we stated it. What we looked at a whole bunch of evidence, particularly from freshwater, pardon me, technical report 3, in order to draw the conclusion that these habitat factors were unlikely to be the primary drivers. It wasn't only the juveniles per spawner data, but there's a whole bunch of analyses in Nellets and all that looked at cumulative stress factors. And secondly, we're not eliminating it as a potential contributing factor. We're saying it's unlikely to be a primary factor driving the overall declines. It could still be a contributing factor in some watersheds, to some stocks, in some years.
Right. If I understand your analysis, then you're really focusing on juvenile productivity, but I'm wondering if you'll agree that there may also be a problem with juvenile viability. And by juvenile viability, I mean the health, broadly defined, of the juvenile fish.
That's certainly possible. If we had disease data from juvenile stages through smolt stages through adult stages, we might be able to test that hypothesis as well as condition information. We don't have that information.
Right, but so you'll agree that it's important to study both productivity and viability. They're 2 separate ways of trying to understand the health.
Yes, I think that is important, and it's in our recommended research and monitoring in section 5.2.
Great, thank you. I'd like to now move to Canada's list of documents, tab 2. We've listed a paper here by Petrosky and Schaller, and I know you've quoted it at page 45 of your expert report. It's titled Influence of River Conditions During Seaward Migration and Ocean Conditions. Are you aware of this paper?
Yes, I am.
All right. And as I understand it, this paper is about the influence of freshwater factors, primarily dams, as you talked in earlier, in the Columbia River, having a delayed mortality impact on the fish when they enter the marine waters. Is that a fair summary?
It's a consideration of both freshwater factors as well as ocean conditions affecting survival rates.
Okay, thank you. This could be marked as the next exhibit.
Exhibit 1903.
And at the top of page 522, which is, I believe, the next, I'm not sure what page that is. Mr. Lund, if you could go to the bottom, it's 522 at the top. So, right, so the top right-hand corner, Mr. Lund, if we could blow up that section there. There's a quote here from the authors that I thought I would ask your opinion about. The top right-hand corner, it says, the NPCC noted that while we cannot control the ocean, we can monitor ocean conditions and related salmon survival and take actions to improve the likelihood that Columbia River Basin salmon can survive varying ocean conditions. Would you agree that this statement can apply equally for the Fraser River for sockeye salmon?
Yes, I would, although I would caution that if conditions in the ocean are really bad, the ability to improve the likelihood may be difficult.
The next paragraph down starts with recruitment success in the ocean environment is generally believed to occur largely during the first critical months at sea. And do you agree with that statement?
Yes, I think that's true for most Pacific salmon.
Thank you. And then over the page, it states, the top left-hand corner over the page, if we could look there, the second sentence says, first-year ocean survival reflects the influence of near-shore and broad-scale environmental conditions, but it may also be influenced by the condition of fish when they reach saltwater due to experiences in an earlier life stage. And I presume you would agree with that.
Yes, I would.
Okay, thank you. And so this concept of delayed mortality or delayed effect, that's something we should be aware of when we're considering Fraser River sockeye salmon.
Yes, we should.
And going back to my question about the importance of monitoring juvenile viability along with juvenile productivity, can you comment on what your suggestions are with respect to how to monitor juvenile viability? What should be done for that?
Well, if we could go to our report on page 108. So the first row of that table says, for parental spawning success and incubation, although an unlikely explanation of past decline, spawning success and incubation could relate to disease concerns and or become a higher priority in the future with climate change. And then as you follow down through there, there's various suggestions on how to monitor. So for example, suggestion number 4 says, assessments of freshwater smolt production and health for a strategically selected cross-section of stocks.
All right. That's helpful. So I understand there's sometimes a debate on where to put resources. Should resources be put towards counting fish at their different locations to capture their different life stations, or should resources be placed to study fish health, to understand the health of the fish? What's your thought on those two monitoring approaches?
I think the first thing you have to decide is what questions you're trying to answer and what decisions you're trying to make. And then what are the inputs to those decisions, and then decide how to collect that information. So, if you're trying to make a decision on harvest, you're going to want very specific information on the expected returns both prior to and within the season. If you're trying to make decisions on what's the long-term future of sockeye and what's happening to them, you need a more comprehensive understanding. So my way of thinking about this is that, and it's not just my way, it's a common way of looking at things, is you try to first identify where the bottlenecks are. So where is survival declining and within which life history stage? And then look within that to try to define what the stressors are. So first understand the survival and condition within each life history stage, and then look within that, those where it appears that there are problems, to understand the mechanisms and stressors.
And in doing that, then you would want to look at both sides. You'd want to look at the health and at the productivity.
Yes.
with respect to, I'd like to now turn on a brief conversation on pathogens. And you've stated that in your evidence this morning and in your paper that it's not possible to reach a conclusion on pathogens due to data gaps. Is that?
That's correct.
And I'd like to compare what this report says to the Pacific Salmon Commission report. If we could go to page 5 of the Pacific Salmon Commission, which is Exhibit 73 again. And page 5, and it's the middle paragraph of the square box. And we're still in the executive summary. And it says in the middle paragraph there, from the available evidence, the panel also deduced that freshwater marine pathogens, that is viruses, bacteria, and/or parasites, are an important contributor to both the poor returns in 2009 and the long-term decrease in productivity. But again, data did not permit distinguishing further. It's conceivable that pathogens picked up in freshwater did not cause mortality until the ocean life stage. The panel members' views on pathogens range from a very likely contributor to a possible contributor to the Fraser sockeye situation. Panel members believe that diseases caused by these pathogens are likely made worse by natural and anthropogenic stressors. So, will you agree that the Pacific Salmon Commission's conclusion on pathogens are considerably stronger than your paper's conclusions?
I'd say they're somewhat stronger. If you'll note in that table, or in the passage you just read, there was by far the widest range of uncertainty on pathogens within the panel, from very likely to possible. And our job was primarily to synthesize the work done by the Cohen Commission authors, and Dr. Kent's report essentially said there are no data. And so I would say that we followed a somewhat more rigorous and perhaps harsher decision tree than the Pacific Salmon Commission panel did in deciding what conclusion we would come to, as I explained earlier to the Council for the Cohen Commission in Table 3.3-3. So with respect to diseases, without data, we were not able to draw a conclusion. And what I found in past areas is that the range of hypotheses and degrees of belief is very large until you actually get data.
Right. But I understand at the Pacific Salmon Commission that there was expert evidence there that Dr. John Winton was present, and he's a renowned expert in the United States on pathogens, and so the Pacific Salmon Commission was able to rely on his expert opinion. Is that not part of why there were this stronger statement was made?
Yes, I think Dr. Winton provided his opinion on it. I would say that the Cohen Commission provided an opportunity to give a more thorough and detailed look at diseases in the work that Dr. Kent had. I mean, Dr. Winton basically went to a workshop, listened to some presentations, and then had a couple of days to work on this. Dr. Kent had a lot more time to go through this a lot more systematically and write a more detailed report.
I'd like to move on now to some questions about stage 4. If we could go back to your expert report at page 91. And here you are quoting from McKinnell in the second paragraph about, and you talked about that this morning, about biologists rarely observe death by natural causes of Fraser River sockeye at sea. Would you agree that in a good year we have approximately 90 to 95% marine water mortality for sockeye salmon?
If you're talking about from the smolt stage to recruits, yeah, marine survival rates in a good year are probably 4 to 6% or something. So I'm taking the opposite of your point of view.
Sure.
But it comes out the same number.
Right. And in a bad year, we have 98 to 99% marine water mortality, or 1 to 2% survival.
Yeah, or worse.
Right. And so we're searching for a cause for an additional plus or minus 5% mortality in the marine stage to explain poor years as compared to good years?
Yes, I think that's correct. And a paper, which I think one of the other participants will present earlier by Dr. Hyatt, shows that you can use temperature and salinity and El Nino versus La Nina events to actually make that discrimination between good and poor ocean survival for some stocks.
And you'll agree that we really don't know the cause of this high mortality rate of sockeye in the marine waters.
Well, I think we can describe the plausible mechanisms. They get eaten by other things. They die of starvation. There are other reasons by which they would die. As to exactly what kills them, no, we don't know that.
You'll agree that dead salmon, the mortality, are rarely found, and without the bodies, you can't really do biopsies or study them to determine the cause.
Yes, I'd agree with that. And even if you had the bodies, you don't necessarily know what killed them.
And that's part of the difficulty in testing for diseases or contaminants, because we don't have the bodies to conduct studies.
That's correct, although you certainly could collect fish, for example, at the trap near Mission, and you could collect fish from the Strait of Georgia and analyze contaminant body burdens and diseases. There's certainly a possibility of doing that.
Right. Mr. Commissioner, I've been given an extra 10 minutes by my fellow participant, the the salmon farmer, so I'll continue through till 12:30, and I may have one or question upon my return.
Sorry, I think you need to finish at 12:30. I don't think there'll be any time after that.
Well, my friend has passed me a note saying I can continue, so I'll speak to him at the lunch break, and I reserve the opportunity to have possibly one question after lunch. If we could go to page 105 of your report, under the section 5.22, synthesis of recommendations, you state, you're talking about your recommendations now. 5.2-1 is a synthesis of research and monitoring recommendations based on the Pacific Salmon Report discussions at the Cohen Commission workshop, then the Commission technical reports, and this cumulative effects assessment. So I'm just clarifying that you started off with looking at the conclusions of the Pacific Salmon Commission, and then you layered the work of the multiple reports, and then your cumulative impact assessment. Is that accurate?
That's correct, and the workshop as it states, yeah.
Okay. And earlier in direct from Ms. Baker, she asked you about, you stated that you need excellent data. You were talking about data improvement, and you suggested that we need excellent data on Fraser River and non-Fraser River sockeye. Perhaps you can clarify the importance of why we need data on non-Fraser River sockeye. We always talk about just the Fraser River here, and I'm curious to hear your explanation.
The ability to test these hypotheses of what caused declines in salmon, as you stated earlier, is very difficult to do directly because you don't have autopsies and the like. And so you're relying on indirect evidence, and what you're looking for are contrasts. You're looking for contrasts in productivity across different stocks, some higher and some lower. And you're looking for contrasts in stressors, some higher and some lower. And so the work on non-Fraser stocks is very helpful for illuminating what's the pattern that we're trying to explain. For example, Columbia River, Okanagan sockeye more specifically, returned in record numbers in 2009, whereas we know the Fraser did awful. And so looking at that helps to illuminate what could be the possible differences between them, in this case, going to a different part of the ocean, going around the west coast of Vancouver Island rather than Georgia Strait and Queen Charlotte Sound. So those kinds of contrasts are enormously valuable.
Thank you. If we could then move to page 29 of your report. This is the Fraser River sockeye salmon productivity chart. And if we could just look at that. And would you agree that for the period 1952 to about 1990, early 1990s, the average productivity was about approximately 6 adult fish returned for every spawner that spawned?
Just eyeballing, looks a little lower than 6, but around there.
We could then move to tab 8 of Canada's lists of documents. This is Exhibit 1851. And what we've done is we've updated this chart with information from the Pacific Salmon Commission. Have you had an opportunity to see this before?
Yes, I have this week, along with 61 other documents.
All right. Last week, Mike Bradford spoke about this document. Will you agree that in 2010, and this is certainly preliminary data for 2010-2011, that in 2010 the productivity returned to its historic average of approximately 6 adult returns per spawner?
Yes.
And what do you make? And then in 2011, it's a bit lower, it's somewhere around 4. But I'd suggest, would you agree that in 2011, that's still within the low range of its historical productivity?
Recognizing that those are preliminary numbers because you don't have the full age structure, that looks to be at the low end of the historical range, yes.
And what do you make of this increase in productivity in 2010 and 2011?
Well, first of all, it's good news. Secondly, as we talk about in our report, in 2008, the conditions in the Gulf of Alaska, and this comes from Skip McKinnell's report, were the coolest they'd been in about 35 years. And that seems a reasonable explanation, since sea surface temperatures are strongly related to availability of food in particular, and other things, as to why the returns in 2010 are better. As to why the returns in 2011 are better, we'll have to look back at conditions in 2009. I know there was I think a La Nina event which overlapped into 2009, so there was somewhat cooler conditions, at least over the winter and so on. So there is that variability, and we were dealt a nice hand in 2008 and a somewhat good hand in 2009. But doesn't mean you'll get a good hand the next game of poker.
So that's looking at productivity. I'd like to have the same discussion about run size. This is showing productivity, but so then in 2009 we have a very, very poor run size, but in 2010 we get a historic run size. And do we need a theory that can explain both low and high run sizes? Is there how do we understand that?
If I could answer your question by going to a figure in our report on page 37 of our report. So the total return is going to be the number of spawners times the recruits per spawner. And so these 4 graphs are organized by brood year. And so in the top left panel, you have the returns 2002, or 1998, 2002, so then that would be also 2006 and 2010, which you can see are dominated by the red or late Shuswap stock. So 2010 had the benefit of both higher recruits per spawner, as you were just showing, like around 6, but also had the benefit of a pretty large cycle year in the late Shuswap stock. And you can see that they're a lot lower. The red is a lot lower in the other brood years in the other 3 graphs. So the total return is just the number of spawners times recruits per spawner. It's just straight math. And when you have more spawners, even if you have the same recruits per spawner, you're going to get more returns. And that's why you can see, over each of those big Adams year runs, you get more recruits.
Thank you. I know the time, Mr. Commissioner.
Thank you very much, Mr. Timber.
Hearing will now adjourn until 2 p.m.